Hello everybody, today we're going to be taking a look at something that's a fundamental, really useful building block of creating UIs and boxes and so on in your UI, and that's called the 9-slice box. Okay, really commonly used for text boxes or any kind of rectangle system in your UI that has borders and shapes, and you can kind of get the idea just by seeing what I'm doing on the screen now. Basically what we do is we have a certain kind of sprite laid out in a particular way that we slice into 9 parts, representing 4 parts for the corners, 4 parts for the edges, and obviously a part for the middle, and then we use that to draw an arbitrary rectangle using those pieces to define the borders and the middle. Okay, once you can do this, it's really useful, and with a certain kind of setup you can even do fancy animations with it that looks something like this, okay, where you can kind of make text boxes kind of appear and disappear in fun and interesting ways. So take a look at this sprite here. This is what I mean when I'm talking about a 9-slice, okay? If I turn on the grid here, you can see I've split the image into 9 equal parts. You see we've got the corners, and the edges and the middle, okay, and using those we can basically tile them using a bunch of for loops and draw an arbitrary rectangle just based on some coordinates, okay. And what we're going to be looking at is how we do that. Okay, we're going to write a script that we can just plug some numbers into and draw an arbitrary rectangle wherever we want. Later on we'll be taking a look at the texture I used just a second ago, the sprite I used to show off kind of fancy animations and stuff as well, with a lower detail version of the sprite, and we'll look at some of the differences involved and what can be achieved if we're willing to sacrifice some detail from the edges here. But first of all, we're just going to use this one where we assume that we've got some detail in each corner that we want to replicate cleanly, okay? So let's get started. Okay, so this is the basic setup for the script that we're going to be using, okay? We're going to create a script called 9-slice box, and we should be able to just, by the time we're done, call this, plug a few coordinates in inside a draw event somewhere, and we'll be able to draw an arbitrary box with borders and so on, just wherever we want to from these coordinates, okay? Exactly the same kind of setup as draw_rectangle, where we provide the top left coordinate and the bottom right coordinate, and we use that to actually draw the box, okay? First thing we want to do is set up a few temporary variables just using var local scope variables that are used once, and then when the script is over, they're discarded, okay? The reason I'm going to do that is just because we're going to write some really long draw sprite part commands, okay? And it'll get really confusing and hard to look at if we're just using argument 1, argument 2, argument 3, and so on all the time. It'll become really unclear what we're doing, and the lines will just get super long, really hard to read, and it'll just be bad. Okay, and this will also help us do some calculations ahead of time, so we don't have to keep repeating them. Okay, and the first one of those we're going to do is called var_size. Okay, which is going to equal sprite get width argument 0 divided by 3. Okay, so that's the total width, and you could also use the height as well of our 9-slice. So if we go to a 9-slice, we can see that this is a 24 by 24 image, and so it's split evenly into 3. Make sure your image that you're using is split evenly into 3, and make sure they're all squares as well. This won't really work with a rectangle kind of 9-slice, okay? It's just not really going to work the way you want it to. And because we know that squares, we can use the width or the height, and we know that in this particular case this is going to return 8, okay? Because each one of these is 8 pixels wide. Okay, so let's come back to our script. So simple as that. That saves us writing this huge line every time we want to know the size. So var_x1 is just going to x1 is going to equal argument 1, okay, and var y1 is going to equal argument 2. You can probably see where this is going. Var x2 for argument 3, var y2 equals argument 4. Okay, make sure you get those the right way around in the right order. Very easy mistake to mess up. Just maybe get like y1, x1 the wrong way around, that kind of thing. Make sure they're in that order, and you're getting your arguments appropriately, okay? You might be wondering at this point why I'm putting an underscore in front of all these things. This is a kind of a new convention for me that I've adopted having seen other people do it, and I think it's a good idea. Just to avoid any confusion, between variables that you're using in a script that you might be using across multiple projects or multiple different objects and environments, just to make sure that these variables don't have any, you might be using a variable called x1 or size or x2 in your actual object itself, okay? And so by putting these underscores on the end, that lets you remember and confirms absolutely for sure that these variables are local to this script, and have no role and no like overlap or conflict with any variables or variable names outside of the script, okay? Just a useful thing to do. And just might help you solve a few problems later on, okay? So we want those variables. There's a couple more variables that we need now as well. The first one is going to be called var underscore w, and that's going to be the total width of our box in pixels, okay? So that's underscore x2 minus underscore x1, okay? So that's our far right coordinate minus our far left coordinate. Okay, the bigger one minus the smaller one gives us the difference between them. Okay, simple as that. Var underscore h equals y2, sorry, underscore y2. It's very easy to make the mistake of not putting the underscore in, but it very quickly reminds you that you don't, because when you do it, it'll stay gray or it'll turn blue, which reminds you that it's not picking up that it's one of your local variables. So you know very quickly that you got it wrong, which is handy. Y2 minus y1. Okay, so the bottom coordinate minus the top coordinate gives us the height. Okay, but we need more than that as well, because as I say, we've got fully detailed things, and we need to know, we're basically going to draw it in columns and rows like a table, okay? So like if we were drawing just this, like the most basic version of the box, we've got 3 columns and 3 rows, okay? So how do we work out how many columns or rows that we've got based on an arbitrary number of pixels? Because we could put any kind of coordinate into this. So if it was like this size, we probably want to draw it like at this, and if it was like this size, we probably want to draw it at this, and so on. So how do we work that out? What I'm going to do is type var underscore columns. So the number of columns is just going to equal underscore w, our width, div size, okay? So it makes it fit into our size. Size is 8, so it divides our width by 8, but returns it in whole numbers, okay? So if it were 80, we'd get 10, right? 10 columns. But if it were 82, we would also get 10, right? Okay, because it would still only go into it 10 times. We have 2 left over. But if it were 88, then we get 11. Okay, so you can see how that works. But rows is going to be the exact same thing, but for the height. So underscore h div underscore size. Okay, same thing again. Okay, so that's all our vars. I know it takes a long time to set all those things up sometimes, but it is important. You'll see very quickly why it's very helpful that we have all these buried into variables rather than just writing argument names and so on in a second. So what do we want to do now in the script? Well, we want to draw 3 distinctly different things. We want to draw the corners of the box, we want to draw the edges of the box, and we want to draw the middle of the box. Okay, these lines are going to get big, so let's shrink this down just a tad. Okay, so we know what we're drawing here. We're drawing these corners, we're drawing the edges, and we're drawing the middle, okay? You really want to make sure that you label each section appropriately and go further than that, and also label which exact piece you're drawing. So label the top left, the top right, the bottom left, and the bottom right, okay? I promise you it's very likely that you're going to make a mistake somewhere in this, and you're going to get a number wrong, or you'll make one number 0 when the next number should have been 0, or something like that. And tracking your mistake can be really hard if you haven't labeled which corner is which, okay? Because you'll see that when you try and run it, your bottom right is messing up, but you don't remember which one is your bottom right, and so on, and which var is which, and so on and so forth. And that's why it's so important to do these variables, and it's why it's so important to label each section, okay? And you'll see as we go through. So let's draw, first of all, let's start off by drawing the top left. So how do we draw a section of our 9 slice? Okay, this is just one sprite, there's no frames or anything in it, although that would be a way to do it as well. We've just split it into 9 parts. So how do we just want to draw this part, okay? We don't want to draw all of the sprite, we just want to draw this section. Luckily, there's a command built in exactly for that, and I think I've mentioned it already. Draw underscore sprite underscore part, okay? Draws part of a sprite, as you might have guessed. And you can see at the bottom here the various arguments that we need to put into this. So first of all, we need to give it the sprite name. That's really simple. That's argument 0. That's the only one we haven't buried into a vargs. Like if you've only got one, it's easy enough to remember, right? Subimage, the frame is always going to be 0 because we've only got the 1. So that's going to be the same every single time. Now we've got the left and top. So that's the top left coordinate that we want to draw from. Well, we can see in here that we want this to be 0, 0. We want it to be the top left, right? Whereas we might want it to be here or here or here or here for the various other parts. But the top left is really simple. It's just 0, 0. So we can just put that straight in. 0, 0 for the top left, okay? And you can see that some of these numbers start to like be the same a lot of the time, so you can see why it can be very easy to make little mistakes. The width is and height is always going to be underscore size, okay? Which we know is 8, because we know this is 24 wide and a division of it by 3 is 8. So we start here and we draw it 8 wide, 8 tall, which gives us this segment, okay? Which is what we want to draw. Then we just have to tell it where we want to draw it, and as I say, the top left is the really simple one, the easiest part. We just want to draw it at the top left, which we know is x1 and y1. So x1, y1. And I would run this now to demonstrate, but we're really just only drawing this top left part. We want to draw a bit more before we actually try it out. So let's now add the top right. Okay, so this is going to start off being very, very similar. So draw sprite part, argument 0, again, same sprite, same frame, but this time we don't want a left coordinate of 0, okay? We want a left coordinate of about 16, right? So not 8, but 16, okay? So how do we get that just arbitrarily? Well, very easily, because we know the size of one of these. So it's just that size multiplied by 2 is always going to get us our third box, okay? Multiplied by 1, or just itself, right, is going to give us our second box. So that's the easy way that we can always find, along the columns and the rows, which area of the sprite we want to draw. So the left coordinate here is going to be underscore size times 2. Okay, and the top, again, is going to be 0, because it's still along that top axis, right? The width and height, as I said before, always going to be underscore size, and then the x and y coordinate, they are going to be slightly different because we don't want to just draw it in the top left, right? We want to draw it at the top right. So this time it's going to be x1 plus the number of columns that we have, okay, multiplied by size, because that's the number of tiles in that direction, okay? And that's going to give us our top right x coordinate. Our y coordinate, though, is going to be the same because it's just at the top, right? So underscore y1 for that. So let's run that now and just see that we can, just check that we can see that that's working. So if I run that, hey, I've already got this set up to just run the command, run the script, okay? And that text there is literally the input I'm putting into the script. And you can see just moving the mouse around, because those are the coordinates I put in. We're drawing our top left of our box and the top right of our box, wherever the mouse happens to be. We can even like really close it off like that and not even have a middle in between. So it's all working as we expect. Okay, so now let's draw the bottom left and the bottom right. So bottom left, bottom right. So for the bottom left, draw sprite part again, argument 0, subimage 0, let's say those will always be the same. Left, the bottom left, as we can see, and it's worth just checking this every time, okay, is 0, because we're just coming along here, so the x is definitely going to be 0, but the y is going to be size times 2, okay? So left is 0, top is size times 2. And you can already start to see why it's so easy to make a mistake. Like, look at all these really similar numbers, just sort of rearrange like one off each. Really, really easy to trip up. So just, it really helps just each time, just checking the argument that you're putting in, going across to your image, thinking, this is where it needs to be, and putting it in. I guarantee you'll probably screw up, make a mistake, but you've always got this to refer back to, right? Okay. So the width. Now, we always know the width is going to be underscore size, and the height is always going to be underscore size. I'll be surprised if I don't screw up at all just during this video. So the x coordinate we know is the left, so that's x1 again, and the height this time is going to be basically what we did here, but for the y coordinate to reach the bottom y coordinate, okay? Which isn't just y2, obviously, and because this wasn't just x2, because it depends on the number of rows, right? So it's y 1 plus underscore rows multiplied by the size, okay? And close the bracket again, semicolon, okay? So let's just run that as well, just running every little step here just to show you. You can see now that is correct, okay? So now let's draw the bottom right. Very, very similar. Draw sprite part argument 0. I won't walk through every single one of these in like complete step by step, so we'll get these in a bit quicker. So size times 2 for the left, okay? Because we want the bottom right one, okay? So we need that size times 2 in both axes, okay? For that exact coordinate. The top is also size times 2, size for the width and height as always, and then it's just both of these things together. So we can just copy this section. So the far right coordinate and the bottom coordinate, okay? y1 plus row times size, and then close the bracket, semicolon. Okay, just running again, super quick, just to show you this running completely as expected. Now we just need to draw in the edges and the middle, and we've got our box, right? So let's go. Okay, so the edges are slightly more complex, but also not really at all, okay? How are we going to do this? We have to draw more than... with here, we've just been drawing literally one sprite for each for the corners, right? But we might have to draw multiple copies of our edges, depending on how big the rectangle actually is, okay? So how do we do that? Well, we just use a simple for loop. Okay, so we repeat it a number of times, and we increase a variable each time for the loop to help us draw a sequence of things. So var I, just a temporary variable, equals 1. When I is less than the number of rows, that's our condition for keeping going, okay? And I plus plus, okay? So then we add 1 to I every single loop until I is equal to, or greater than, I suppose, although it would never reach that point, equal to the number of rows, okay? The reason we start at 1 and we do it when we're equal to the number of rows is to account for the corners, okay? So we don't draw over the corners that we've done. So left edge, first of all, okay? So this is the edge that's just going to be the left edge, right? I don't need to describe it more than that, I guess. Draw sprite part. Okay, argument 0, again. That's the sprite. Subimage 0, again, as always. Left is 0, again, and top this time is going to be size, okay? Because that gives us this position here, okay? And width and height, size, as always. Oops, there we go. And this is where it gets a little more complicated. So the x coordinate is going to be x1, because it's always just going to be the left, but the y coordinate is going to be y1 plus I multiplied by size, okay? So it's whichever, because we're going down the edge, so the number of, for each row, I multiplied by the size is going to be 1 times the size, and 2, and then 3, and so on, and then it'll draw the whole edge, okay? Simple as that, really. Close the bracket, semicolon, boom, that's our left edge. Now let's draw the right edge at the same time, so draw sprite part, argument 0, because we're cycling through each row here, so we may as well do the left edge and the right edge at the same time. Frame 0, but this time the left coordinate is size times 2, because we want the right coordinate, okay? And then the top is size, again, because it's the middle one. Width is size, height is size. The x, in this case, is x1 plus columns, sorry, that's underscore columns, times size, okay? That just gives us the far right edge, okay, just as we were doing up here. And then, the same as we just did above, y1 plus I multiplied by size. Okay, it's getting a bit big. Let's shrink this down just so we can see it all at once, okay? So that gives us our left and right edges. So if I run that now, we should easily see that this is working. So we've got our left and right edges coming in here, okay? Just drawing the appropriate number for however big this should be. Okay, cool. So just to save a little bit of time, I'm literally just going to copy and paste in the section for the top edge and bottom edge, because it's exactly the same. It's exactly the same as doing everything that we've done so far, okay? Finding the correct coordinates for getting this and this, which I think is like size 1 left, and then 0, and then size 1 left, and size times 2 for the bottom one, right? Simple as that. And then just flipping around how we do the I times size thing, okay? So instead of applying that to Y1, we apply it to X1, and the exact same thing for the bottom, right? Works exactly the same way, and we can see that very simply now. Just working. So we've got all of our box other than the middle. Hell, you might even want to leave it at this point. That might be a useful script for you to have as well, just to leave a completely transparent middle. Completely up to you. But here's how we create the final middle section, okay? So the middle section is basically just going to be the same thing that we did for the edges, but instead of just doing one for loop, we're going to do two, because we're going to cycle through every column and every row at the same time. So for var I equals 1 again, I is less than the number of columns, I plus plus. Okay, so the exact same thing, just for cycling through every column as we just have above here, okay? And then we basically do the exact same thing again inside. We do another for loop for var j this time, because we obviously, I is representing the column that we're on, so we need a different variable. J is right next to I, so it's pretty simple. Var j equals 1. J less than, this time, the number of rows, J plus plus, okay? So for every column, now we're going to loop through, just make sure the arrow goes away. So for every column, we loop through every row, okay? So on column 1, we do this until that finishes, and then we go back to this again, and then for the next one, we do that until that finishes. So it's a loop of loops, right? I don't know why I've given us so much space in here. We actually only need one line on this, which is draw sprite part, argument 0. We know the sprite, we know the subimage, and we know the middle is going to be underscore size, underscore size, right? Top left is going to be left 8, and bottom 8 gives us here, okay? This is the 8x8 pixel. That's what we want. I don't know, semicolon there. Underscore size for the width and height. And the x and y position is very simply going to be x1 plus I multiplied by underscore size, right? And the y position is going to be y1 plus I multiplied by underscore, not y, sorry, j multiplied by size, because that's for each row, we want to draw it at a different y position, and for each column, we draw it at a different x position, right? Simple as that, and that's just that one simple, clean line of code in there. With that loop, we'll draw the inside of our box, and there you have it. Hopefully, we have our full box drawing, nice, properly textured, however big it needs to be. Obviously, the minimum you're really going to want to do it is like like a 16 by 16 box like this, right? Because if you go any thinner than that, you're going to get problems, because, you know, I mean, why would you anyway, right? And you go any smaller than that, you'll end up with problems. You go negative, you'll end up with all sorts of issues. See, it doesn't even draw the inside there, so make sure that's the top left and the bottom right used appropriately. So one issue is, because of the detail we've added here, we kind of have to draw this tile by tile, right? So you can see here, it's not responding to my exact mouse coordinates, it's dividing them and snapping them to the kind of grid, the 8x8 grid on which we can kind of draw this box. Which can be fine, and that lets you do all kinds of UI stuff very, very well. But if we want to do some cool extra animated effects out of this, we can get them by sacrificing some of the detail of the sprite that we use. So let's close this and just go to our nice side. So we can see we've got some, we've got quite a few different unique pixels going on here. But if I look at this version, as I think I brought up very early, every column you can see of this tile is the exact same column of pixels, right? Every row in here is the same row of pixels, and all of these pixels are exactly the same, okay? So what that allows us to do is we can still draw these corners the same way we've been drawing them before, but instead of like using a for loop and drawing each block of this as like a tile and creating kind of a table that way, we can just draw this 1 pixel wide segment here and stretch it to the width of our box, and we can just draw this row and stretch it to the size of our box, okay? And we can literally just take 1 pixel here and stretch that, okay, to the size of our box. So how do we do that? So what I've got here is an alternate version of the script, okay, which doesn't have any of the for loops that we had in it before. This one's called 9SpliceBoxStretch because it allows us to stretch our box to an arbitrary size that doesn't have to be, or doesn't end up divisible or divided into 8, or the size of individual tiles. So how does any of that work? So drawing the middle, which I've moved to the top here just for safety reasons. It's always safe, I guess, to draw the middle first, so that if we screw anything up with our corners and edges, they at least get drawn over the top. Shouldn't ever happen, but you know, so it's probably the correct order to actually do it in. So for drawing the middle, what I've done is instead of using drawSpritePart, I've used drawSpritePart.ext. We no longer have our for loops going on. What we're going to do is we're going to grab this 1 pixel here, and we're just going to stretch that, okay, to fill the box, because all these pixels are the same anyway, so we can do that and it'll look right. So how do we do that? Well, all we have to do is where we did the width and height before, instead of using size, which is 8 by 8, we're just going to grab that 1 pixel, so I'll just put 1 and 1. Doesn't really matter since all the pixels are well, it matters a little bit. Doesn't matter too much because all the pixels are the same. But what drawSpritePart.ext does is it gives us a few extra functions that we can put into this command, namely the X scale, Y scale, color, and alpha of how we want to draw the sprite. Okay, color and alpha are relevant to us, so that's just the basic. C white is the default color blend, and 1 is the transparency. We just want it to be solid, fully opaque, right? So just C white, comma 1 for those last 2 parts. But this part here, X scale and Y scale, what I've done is the width minus size times 2, okay, because we want to account for the corners, and I've added also size to the X and the Y coordinate again just to account for the corners. Okay, so it's drawing in the middle and not overwriting and not drawing where the edges should be, because we want to draw the exact width of the box just minus the width of the edges itself, and the exact height of the box minus the width of the edges itself. Okay, and then that just fills in with a rectangle the middle of the box, and we do a very, very similar thing for our edges. Okay, so instead of using the for loop where we go through every column width, we just draw one thing here, and with the width and the height for the left edge, for example, the width is still size because we want the whole width of the grid of this particular tile here, but we don't need the whole height here. We just want this 1 pixel here. So then we can just use the Y scale of that just to multiply it by the exact number of pixels that we want. Okay, that's why we're only grabbing 1 pixel rather than the whole thing. Okay, because then it would have to we'd have to take the number 8 into account, whereas just 1 here, we know it's a 1-to-1 relationship with the Y scale. Okay. So that's how it works then. So that's 1 pixel there, so we grab that little slice there, and for the Y scale, and as I say, for where we want to draw it, it's Y plus size, so down from the corner, so we don't overwrite the corner. The X scale is going to be 1, like 100% X scale wise, but the Y scale is going to be the total height of our box, minus minus enough to account for the 2 corner pieces, okay? And then the exact same thing applies to all the other edges, okay, just done for the different coordinates and different sizes and shapes. So let me try to show you how that actually ends up. I know I've gone through that very quickly, but hopefully you get the idea at this point. You can see now this is like really arbitrary now, so we can draw it like at a completely arbitrary. Obviously if we do it too small, it starts to screw up. You still want it to be about like the size like this, at about a minimum, right? But it allows us to sort of scale it pretty freely. And pretty specifically. You can get more of an idea of how this is a cool thing if I press enter now, just to show you, like, you can do this kind of thing and have boxes that just sort of appear like neatly and smoothly like that. Okay, if you want to get your hands on the source code for this, Patreon supporters, I think of $5 or more, will already be able to access that. But I'll probably also make this available on itch.io and maybe the asset store on GameMaker as well. Just so if you have a couple of dollars and you don't want to become a monthly pledger just to get access to this sort of thing, you can just go give me a one-off payment of a couple of dollars and you can get it there. But this whole video has shown you how to do it all, so I guess you don't really need it. In terms of how you actually use these scripts, you can see exactly the sort of numbers that I've put in at the top here. Like, that's exactly how I've used it. That's mouse X and mouse Y, just to draw it to wherever the mouse is. And then minus W and plus W, that's just adding an amount that I'm waving between 2 values here to create this kind of fun effect, okay? Thank you all for watching. Hope you guys enjoyed that one, and I'll catch you guys next time. It might not be next week for a tutorial video because we're coming up to Christmas, and I've got a lot of extra meta stuff I need to do. So it might not be until after Christmas until you get another tutorial video, but we'll see how it goes. If you're a Patreon supporter of mine, there'll be plenty of updates there, or even if you're not, I'll probably post some public updates there and links to them from Twitter and so on and so forth, so you can keep track of what's going on with me. Okay, again, thank you all for watching. Catch you guys next time. A huge thank you, as always, to my Patreon supporters who allow me to make this kind of work. Huge apologies in advance if I screw up any of these names, but a big shout out in particular to Dogan Techben, Dan, Inner Mule, Ryan Senecal, Giles Montgomery, Harold Guidry, Nathaniel Walsh, Lewis R. Pereira, Nick Slavish, Stephen Hagen, Jason McMillan, Shawnathan, Owen Morgan, and Bowser the Dog. Thank you all very much, and I'll catch you guys next week.